Good day, everyone. Welcome to Structural Design 424. It's good to have you back for the year. We have another possibly challenging year ahead of us with COVID, but hopefully we'll make the best of it. And as we start with a hybrid year of some face-to-face, some online, we're going to make the most of it, and hopefully it's even more successful than last year. And at least we will get to see each other a certain amount of time in class. And in this session, I'm going to be giving you an overview of the course, introducing you to some of the concepts, some of the what we're going to be going through, and the basics of the course. So just as an overview, going to give introduction to myself, then course content, textbooks and codes, assessment, tutorials, what to take away from course, steel structures, making steel, etc., and then some standard sections. Some of these you can go through yourself afterwards. So firstly, I'm Professor Richard Walls. I'll be taking you through this whole course, and my background is actually a professional structural engineer. I was working in Joburg on heavy industrial and petrochem, and then joined Stellenbosch some years ago and have been teaching this course the last few years, but also teach postgrad, especially in fire engineering research, do quite a lot of that, and well, primarily that these days, but also concrete design and various other courses. And then now in terms of the course content, this is going to give you an introduction to steel design, and it is a sort of an introductory course, a first course in steel, and we will first cover just an introduction to, well, what we're going through now. Then we'll look at loading shortly, and then both dead and live loads, or permanent imposed loads, and wind loading. Then we'll go through tension members, which are the simplest members. Then we'll go on to compression members, or columns or struts. They start experiencing buckling, so get more complicated. Then we go into beams, which are more complicated than that, bending and shear. And that's all in the first quarter. And in the second quarter, we're going to do building and conceptual design, beam columns, base plates, connections. What you will find with the course is that the sections build upon one another. So often people say, well, in the final exam, A2 and A3, is the first quarter's work going to be tested? Well, inherently, everything builds upon each other. So you will use tension and compression and bending in building design, beam columns, base plates, connection. So the concepts keep repeating themselves. So make sure you understand them as we go, especially this first quarter, because you will be using them the multiple times, the concepts. Now, in terms of the textbooks, you will need the South African Steel Construction Handbook, the red book. You will definitely be using that, and as soon as we start with tension elements, you need that. Initially, we will be using the SANS one. Well, we'll also soon be using the SANS 10162 Part 2, Structural Use of Steel. So that is the actual SABS or SNS code. You'll need a copy of that for steel design. In terms of the codes, we are going to be using SANS 10160, so the loading code. In the past, you had to buy parts 1, 2, and 3. This year, you only need part 3. Parts 1 and 2 we will be covering in the notes, and so part 3 you will need to go there. Make sure you will need it. Well, make sure you have a copy of it, because we will be starting with it immediately, and you need it for wind loading. But as I said, 10160 part 1 and 2 we will go through in the notes. You don't need to buy a copy of that. You'll also have class notes, and then a set of Prof. Danaiski's original notes have been provided. So an excellent set of notes. He was a professor that lectured this course a number of years back. Some of the details have slightly changed since then in terms of steel grades and some other details, but in general, it's a very comprehensive set of notes, a lot of worked examples. We will not specifically be looking at those notes in class, except for perhaps 1 or 2 examples, but there's a lot of extra content. So if you're struggling, please go get hold of those, look through them. They provide a lot of useful information. And then the green book, we used to use it. We no longer need that as well. We've just been trying to cut down the book list to bring down cost. So the green book is a very, very useful resource, but you don't need that. In terms of content, tutorials 15%, class test 35, exam 50. The module framework does provide the information, and then we'll publish marks according to the faculty regulations. Now, our tutorial is currently scheduled Thursdays. This is subject to change based on a number of recent happenings. It is very likely that this is going to be varying week to week. I will let you know soon what's happening with that based on a couple of recent announcements. If you have questions, ask them. We will have a weekly tutorial period, then after class if we have classes, and then if you can set up appointments, etc. This year we also have forums and online sessions, etc. So all of those are available for you. Our assessments, open book. Everything is 100% open book. You can bring in anything in terms of open book. You can print out every past paper, tutorial, friends' homework that you can find. And you can bring them with you. Normally, people end up shooting themselves in the foot by doing that because they end up with so much material, they just get lost and they spend hours rifling through papers. And it's normally conceptual. It's not, the exams won't look the same as a previous one. So, yeah, so just be careful of that. The desks are small. Tests and exams will be more conceptual. They will be different to TUTS past papers, so don't expect to blindly follow oiled exam memos. You've got to apply what you learned. And then additional questions have been added tutorials as students asked for more examples last year. So in terms of the course, this was 2016, the day after test week. And if you are going to make a good meme about the course, at least please someone send it to me. I could at least have a chuckle as well if you're going to produce memes. The course marks often are a struggle. This is the 2017 and 2018 mark. And so you'll see A1, A2, and final. So in each of these cases, all of those people failed and had to write A3, and some of them passed after A3. And just a warning, a lot of people think, well, I'm just going to leave it to A3. If you have a look at the 2019 marks, you'll see A1, A2, and A3. Be careful of skipping A1 or A2 because historically often it hasn't been the best idea to write A3. Rather try get it done in A1 or A2. So just something to think about. These numbers are probably 2 years old, but so they're probably a little bit on the low side. But what's the cost? Why should you start working now? And let's work out the cost of repeating a year. So tuition fees, I think they're about 50,000. Maybe they've gone up now. Residence and living minimum 100,000, I suppose, depending on where you are living or renting, whether you're at home or whether you're in Stellenbosch. And now, if you fail a year, you will need to spend those first two again. And however, you will lose out a year of work. So you will lose out a year of income, plus then in the second year, you will get a lower income because you have zero experience, etc. And if you add that up over your career, it basically is the same as losing your last year of income. And many of you will end up being senior engineers at companies, so it's very easy that you might earn a salary of 1.5 million. So you add that up, and if you're roughly costing yourself about 1.65 million rand per year expended, extra spend at Stellenbosch. So if you spend 5 hours extra per week on a course and it prevents you from repeating year, you'll effectively be earning. So let's say you put in 60 hours of work extra and that saves you from failing. It's roughly almost 30,000 Rand an hour. So that's quite a reasonable salary, if you could look at it that way. If that will help push you through, it is very expensive, the time value of money. So things like Facebook, washing Games of Thrones, whatever you do, they can be very expensive hobbies if they prevent you from graduating. I do understand that, especially in COVID, there were a lot of extenuating circumstances. So unfortunately, for various reasons, some people did get held back. And I mean, for some people, there was no shame in that. I mean, it just various things went wrong last year, but by all means, if you are in a position where you can prevent yourself from spending another year here, rather do that. Pedagogic approach. Now, I'm just going to present some cynical stuff just to help you make you think about things, and this is based on teaching this course for 5 years. And what I'm about to say doesn't apply to, I suppose, the top sort of 60, 70, 80% of the class, but you're down here. We are more than willing to help you. We have a very dedicated team of demis, TAs, learning assistants, and all the new names we have for demis and TAs. We're more than willing to help you. There are good resources. There's past papers. There's all sorts of resources being provided for you. So we will happily help hold the rope to you so you can pull yourself out of this hole called fourth year. Um, it Enjoy it while it lasts. University is often, you think it's worse than it is, but really enjoy university while it lasts. But we can't get you out of there for you. We'll provide as many resources and as much help as you can get. But unfortunately, what I have seen in the past way too many times is we provide the resources to people and they sort of almost expect us to pull them out, and rather they end up kind of hanging themselves because they only realize too late that, hey, having all of this is not going to magically help me in the exam. You need to start learning early. We are more than willing to help you, but it's up to you. If you put in the time, put in the effort, we will most certainly be there. But I don't know how many times after A2 when people are studying for A3, you speaking to them, I realize that they just haven't applied themselves earlier on, haven't focused on understanding concepts. So please, I would love to see none of you next year. Let's hope that is possible. So just going on about with assessments, non-programmable calculators can be used. Also, get the textbooks. This is now all changing. So this is in the past, tutorials were compulsory. That is now falling away because of the online system. TUT tests are compulsory, but the details regarding those will be communicated. This has changed in the last few days, exactly what's going on. This will be communicated soon. As I said, there will be TUT tests. Sick notes refer to faculty policy. Your lowest TUT test mark will be excluded from your semester mark. If you're sick or have a valid excuse with proof, please send them through. And doctor's notes you can send to me, but typically speaking, we don't need doctor's notes anymore. Your lowest mark is excluded. Not all the information is in the course notes and the books. You will need to take notes from online lectures. Things that have been verbally said could easily be included. So make sure you focus on understanding rather than learning, and probably this is where most people make a mistake in the course. They think they must learn, I will do A, then I will do B, and then I will do C, and that's how I solve every bending problem. And sometimes that's assuming you're starting at A every time, where sometimes we might give you C and then say, well, work back and figure it out. So a lot of people, by not learning the concepts, they just try to learn methodologies and then they get themselves in trouble. So please start working soon. As I said, I'm going to harp on that because many people wake up too late. So what to take away from this course? A better understanding of structural design, a basic idea of modeling, how to actually get loads and analyses done, and then design methods for standard elements, compression, tension, bending, shear, combined forces, and then design of simple connections. This will, if you go into structural design, you will immediately learn the concepts you learn here. You will immediately be able to design parts of buildings when you leave the university. However, it will take some time and senior supervision in industry before you'll be able to confidently and safely design steel structures, but you should hopefully obtain the basic tools from this course. With textbooks and senior people, you could soon be designing great structures. And so, in terms of the definition of this course, this is a fourth year requirement. If your exams don't look like this, they're actually not on fourth year level, and then we shouldn't be accredited as a university. In order to solve problems, you require in-depth fundamental and specialized engineering knowledge. They are ill-posed, under or over-specified, or require identification or refinement. You will be given problems where you do not have all the information. You have to make assumptions. There are high-level problems, including component parts or sub-problems, or unfamiliar, involve infrequently encountered issues. So you will be given things where you haven't got all the information, or you've got too much information, and you'll need to decide what you need to use. But as I said, the work you cover here can be immediately applied, and you can then start designing structures. This is a structure in Sandton, around the Sandton Shopping Centre. Very, very complex, geometrically intricate structure. There's the Cape Town Stadium, bottom right, and then this would be a sort of a typical warehouse that you'll be able to design. Now, when you look at steel structures, just start thinking through them and thinking, why do they look like they do, and how do they fit together, and where are the loads carried, and why are the different components there? Here's some other interesting structures. This is the Norton Rose building in Santon, with some very interesting curved facades. The Sasol head office, we'll look a little bit at that later, and then Alexander Forbes and various others. So these are some very interesting projects being done in South Africa by South African structural engineers. And just think how you might turn one of those into an analysis model and ultimately break it down into a bunch of compression, tension, and bending elements that you would apply what you're using in this course. And often it's how do we simplify a complex problem into something we can safely design. And if you don't understand, with either bad construction, bad design, whatever it is, this is what can happen if we're not careful. Now, just for a second, pause the video, look at these pictures, and think what might have happened to this building. It's a big warehouse, it's on the ground. What may have caused this structure to collapse? Just give you a second, pause it, think why might it have collapsed? Firstly, there are various reasons that this could have come down, and I do not have a copy of the final incident report. This was sent to me by someone else. But what does appear to have happened in this one is that there was a main connection that snapped up at the top, was affected, but it was heavily affected by the loading on the roof. They were busy sheeting it, and then you design it for, let's say, 5 or 10 kilograms a square meter of sheeting, and during construction they piled a lot of sheeting in one place and overloaded the structure. So it was a lot of heavy steel on top and overloaded structure, and it came down. So some things to think about in reality. We have to be careful about what happens in life. So after that, I'm going to very briefly go through making steel and the process. You'll see in Prof. Danaiski's notes, this topic is covered in quite a bit of depth. We will just be doing it a fairly basic level as shown here. It's steel's produced in a blast furnace. It's mined at Sishen, Tabazimbi, Rosenekal in South Africa. And the main materials used when producing steel: iron ore, limestone, and coal. And there's the finished products are iron, carbon, impurities, alloys. And we produce it in shapes: slabs, ingots, billets, and blooms. So you'll hear that in the construction industry, those sort of terms being thrown around. They're shaped, formed, or rolled, and so the forming of steel can look like these sorts of processes. And this is hot rolled steel. So you have a bunch of different steel plates, and they end up getting hot rolled and formed together. The properties that we will typically be using are listed here. So if you need these properties, have a look. I have highlighted this one in red because when you get later to bending design, you get asked for a G value and everyone's forgotten where it comes from. It is listed here. And this is density, elastic modulus, shear modulus, etc. So one thing to remember, steel's about 7,850 kilograms a cubic meter. It's quite a lot heavier than concrete at 2,400. So it's kind of 3 and a bit times more heavy than concrete. So very heavy material, but it's also fairly expensive per ton. So we use it very efficiently, but our sections are much lighter than concrete elements. Temperature has a significant influence on steel's properties, but we will have a look in fire design. We'll do a basic design of steel at elevated temperatures. Now, here is the typical stress strain curve. We start unstressed, we load it up, we load it up, we load it up, and then we hit our yield stress, where more or less it starts then becoming linear after that. We keep loading and loading and loading. There's work hardening, and then finally you have ultimate. And that's the point where the maximum load it can carry. It will start losing capacity after this, and then eventually get to fracture. But so it'll get longer, but it'll actually start losing load in your machine if you have a machine that will allow the load to decrease. But if it was just hanging for something after this point, it would snap quite quickly. So we have two main stresses, a yield stress and an ultimate stress. Most of the time we use yield for safety. If your material yields, it starts getting a lot longer. You can see yield is there, ultimate's there. That's a lot of strain. That is the steel getting very much longer. And so that becomes a problem as the whole structure distorts. So normally we use yield, but there are cases you'll see soon where we use fracture and well, the ultimate tensile strength. Often we simplify this to bilinear, straight line, um, just a straight line up and a straight line across. Often we just assume it's linear elastic and then perfectly plastic, and that makes our life a lot easier in terms of design. And in South Africa, the main properties of the steel are yield of 355. This is the S355JR. That's the most commonly used steel grade in South Africa at the moment. So most of the steel we use is S355. And so for general steel, for everything from 3 to 16 mils thick, which covers the bulk of the sections, we use a yield strength of 355. For thicker sections, anything between 16 and 40 mils, use a slightly lower stress. In the forming process, it doesn't get up to the same yield. And so this really only applies to bigger UB 533 by 210 and 305 sections. So these are types of sections: universal beam, universal column. There's our ultimate strength. We used to use a 300 WA or a 350 W. And you will find at times also commercial grade or commercial quality. This is unidentified structural steel. It's not found in other countries. It is a sort of a, if you go down to the hardware store and there's some steel there and you're not quite sure what it is, treat it as commercial grade. And there are your properties: a 200 MPa yield, a 365 ultimate stress. So a steel structure can consist of almost any type of steel structure section available. We as structural engineers need to select the sections that have the best bang for our buck. We need to make the structure as economical as possible and see how do we get to an efficient structure. We will select I-beams or H-sections or channels or angles or circular hollow sections to come up with a structure that suits our client's needs. Maybe it's for aesthetics, maybe it's for cost, maybe it's for heavy resistance or durability. There are various competing alternatives. And so standard steel sections are cut up and fixed together in almost any way to form the structures needed. And then what's a lot easier is if standard details make structures cheaper and easier. So if you use standard details, the guy making the steel work it becomes quicker and faster. It might be a slight bit heavier if you use standard details rather than redesigning every connection, but normally the final cost of a simple structure is normally cheaper than a complex structure. Being able to connect steel elements is also very important. You should be considered what type of connection. And then structures are normally shop welded, site bolted. So in the factory, you will weld up all your pieces, and then when you get to site, you will bolt it together. And so then you'll bolt it all up, and then you don't weld on site. You only weld when you have to, because quality and access regions. If you're welding 10 meters up in the air, you can make mistakes, and safety and getting there to inspect the welds becomes a problem. So you weld it in a factory and then you bolt it together on site once it arrives. And so have a look through these standard sections and their usages. This will give you some typical sections and their advantages and disadvantages and why you would use each one of those. So please go read through those. And then finally, there's no such thing as a perfect design. It's a balance between safety, aesthetics, and cost. So there's no also single solution. And so you'll need to weigh up what is the best way forward. And so fabricated and erected structural steel costs roughly 30,000 Rand per ton. This number's a couple of years old. It's probably a bit higher by now. But complicated buildings with lots of cuts, welding, wastage, and connections will be more expensive than simple structures with standard details. Hence, the lighter structure is not always the cheapest. The South African Institute of Steel Construction has produced good guidelines for economic design and construction. And then in the real world, you won't be given the structural configuration, bending moment, or section size. So in this course, you will be told, here's your bending moment, here's your beam size, is the beam strong enough? Your client's not going to do that. Your client says, I need a building, I need a floor, I need a support for my silos, my ducts, I need a tank or a tower for my water tanks. You need to figure out the whole package. First, you work out what's my geometry, what are my loads, and then come up with a solution. And so we're only going to be doing steps of this, and just realize that in reality, that's not how things work. You've got to produce an entire system, and then from that, you will end up ultimately checking, can my column that supports my silo carry 1,000 kilonewtons? And then you'd run through the calcs we've done here. So with that, that gives you an overview of the course. Hopefully now, as the sections we go through, they'll fit together and you'll see how they fit into the bigger picture. And then with that, enjoy the course and let's get on to the rest of the sections.